Did you come to Python from the academic side of the world? Maybe you got into working with code for research or lab work, and you found that you like coding more than your first field of study. Whatever the reason, many people make the transition from the academic world over to tech and industry. On this episode, you'll meet 3 women who have made this transition, and you'll hear their stories. I'm excited to speak with Jennifer Stark, Kaylea Haynes, and Eslene Bikoumou about their journey into the tech field. This is Talk Python to Me, episode 259, recorded April 6th, 2020. Welcome to Talk Python to Me, a weekly podcast on Python, the language, the libraries, the ecosystem, and the personalities. This is your host, Michael Kennedy. Follow me on Twitter where I'm at mkennedy. Keep up with the show and listen to past episodes at talkpython.fm and follow the show on Twitter via @talkpython. This episode is sponsored by Datadog and Linode. Please check out what they're offering during their segments. It really helps support the show. Kaylea, Eslene, Jennifer, welcome to Talk Python to Me.
Thank you very much for asking me.
Thank you very much for having us. Thank you.
It's really great to have you all here. I was in a PhD program. My wife is a professor. So I spent a lot of time in the academic world. And I saw that you all were participating in this, I think at the time was going to be a live event around sort of sharing stories going from academia into more the tech side of the world. And I thought, oh, what a fun topic. I have to reach out to you and have you all on the show. So I'm happy you're here.
It's great.
Great. Thanks for reaching out.
Yeah, absolutely. It's a really interesting story how people spend so much time working on, getting a PhD or getting some academic position. And it's just, I find the whole academic space is really different than the tech space. And just to give folks a sense, like the story for my wife, if she wants to change jobs, like there's only a certain time of the year that jobs are kind of offered, right? Like interviews are done in January and you apply to them and there's like 30 or 40 in like a very specific area in the world. And it's just such a different world than the tech space. But at the same time, college campuses are beautiful places. Like the energy is just, I love being on campuses and whatnot. So it's just such a trade-off to make, I think. So I'm really interested to dig into that with you. But before we get specifically to that, I want to start with your story. How did you get into programming in Python? Jennifer, you go first.
Yeah, well, it's by accident. So I was working in the US at the time in Baltimore for the NIH, and it was during the recession, I guess, so 2009, 2010. So the funding was frozen for a number of years. So we had to cut back what we were, like the fancy, it wasn't even that fancy, but software we were using and use open source software. So we started with R. So I learned R.
Okay, nice. And what were you using before? Was it like MATLAB or SAS or something like that?
Yeah, some MATLAB and some other statistical programs that were made. Actually, some of those were also open source, specifically for the kind of data that we were analyzing.
And this, I'm guessing, is in the health and medical research area if you're at NIH?
Yes, it was NIDA, so National Institute for Drug Abuse.
Yeah, so you learned R, and then somehow you got from R. Are you doing R only, or are you doing R in Python now?
Currently, I've not used R for a really long time. I moved over to Python because the kinds of things I wanted to do broadened, and Python's good for so many things. So it just seemed like a natural step for me.
Yeah, I think that's a trade-off a lot of people have to make between R and Python. I feel like R is very specialized and it's very powerful, but then Python allows you to say, like, I have these same skills. Oh, and I could go build this web app, or I could go build this other thing that is not actually just about visualizing and processing data.
Yeah. I mean, I think the last R package I used was for looking at diffusion. And the only place you could find that could allow you to do kurtotic diffusion was an R package. So like that's how specialist it is. It's amazing.
Yeah. Wow. Very cool. Eslene?
Yeah. So I started, I learned Python when I was in my second year as an undergrad. So in my first year, I was using MATLAB, and my second year, I was introduced to Python. So
nice. And what were you studying?
I was studying maths. So I did a degree in maths, and I just fell in love with Python. So since then, I've just been using Python. But it was good. Yeah,
very good. And I also was working in math for a long time, and it's a fun world, but I got to say I like programming better.
Yeah.
Kaylea, how about you?
Yes, I went to university to study physics. And then after a few months, I realised I didn't really like physics. So I moved into a maths and statistics degree. So I've got the statistics background. So I've come from R. So I think I must have learned R about my third or fourth year undergrad. And then from that, I then decided to go and do a master's and then a PhD in statistics. I've sort of got quite a strong R background. And just recently, I guess I'm trying to learn Python, but very, very like beginner level. And I guess that me and Jennifer sort of know each other through like PyData and R Manchester.
Nice. And I guess it's worth mentioning that you all come from the same town, Manchester, in the UK. So you could actually see each other at meetups and whatnot, right? Not just necessarily online.
In the old days.
Yeah.
Yeah, that's super cool.
Yeah, we're all in Manchester now, but none of us are from Manchester, I don't think.
No.
Yeah. Well, and we'll get into it later in the show a little bit maybe, but the idea of getting together and seeing each other right now is kind of, you could be on the other side of the world. It's still a weird time. So yeah. Well, I guess, I hear a little bit of your story and how you got into these various areas, but what got you interested in sort of computational side of computers and programming and whatnot? I mean, Kaylee, go in reverse order, I guess. So if you're not into physics and you want to switch into math, like when I was in math, it was pen, paper, chalkboard, right? Like let there be a theorem. It did end up doing a bunch of cool like visualization work and stuff near the end. But it definitely didn't start out that way. It started out with, okay, we've got, 7 axioms and a corollary, and you've got an hour to like come up with something. Yeah, right. So what got you sort of going down that path?
So I think the reason I changed from physics to maths was I didn't really like the practical lectures at the time that I was being taught when I went to university, which is sort of interesting now because I'm more interested in the practical side. But I think first year physics when I went to uni was very basic and very boring, and I remember I always go back to the same lab that we had where we just had to swing a pendulum for an hour. And I'm sure that's interesting to some people, but it just really didn't interest me at all. So then
I hear you.
I had moved into maths and statistics. I just had this really great lecturer in statistics in first year who was so enthusiastic about data, which I think that sort of helped seeing someone else be so enthusiastic about it. So then I decided that statistics was the degree that I was going to do. And I think, was it like my third to fourth year? So we do 4-year undergrads up in Scotland. So I think in between the summer of my third and fourth year, I then decided to go do an internship at Lancaster University, and they had a really good doctorate training centre on statistics and operational research. And that was really interesting. It was sort of like an 8-week programme where you got given a stats project to do, and it gave you an insight into doing a PhD. And the doctorate training centre at Lancaster is sort of built up and geared towards giving you an insight to doing statistics, but in industry. So it gave us a real practical sort of use to our data. So as you said, a lot of maths was theorems and just different feature spaces and geometry, which was all a bit abstract and something that I can't really bring my mind to visualizing. Whereas I'm more of I like to see the data and the insights and see plots and visualizations.
Yeah, I think having some kind of concrete project like that it completely changes how you experience it, right?
Yeah, definitely. And it's sort of, you can then see actionable insights and you can see the point. Whereas I feel going down a more theoretical maths route, it's quite difficult to see, well, for me anyway, what's actually going to be the point of this at the end.
It's a little bit how I felt as well. I felt like it was, okay, now at some point you just start solving these abstract problems for the sake of, well, they've solved them up to here, so the next logical problem someone's got to solve is to keep pushing it. But it's well, I'm not really sure what this is contributing back to the world, compared to so many other things that you could do. For example, healthcare or something. So yeah, that was sort of my thought as well. Eslene, how about you?
So when I did my degree in maths, I did pure maths. So that was even more abstract, but I quite enjoy it. I really enjoyed it. And so after my degree, I didn't know what to do. So I wanted to get into accountancy. So at the time, I wasn't thinking about big data or anything like that. So I had a conversation with my final year project supervisor. So can I mention his name? He means a lot to me.
Yeah,
his
sure.
name is Dr. James Burridge. So we had a conversation about what I wanted to do after I graduated. So I told him about getting into an accountancy firm. And he said, have you considered about, doing a PhD? So I thought, in my head, I was thinking, oh my God. But I did say yes. I did say yes because I really enjoyed doing my degree in maths, especially my final year project. I loved it. I really enjoyed it. So I did say yes. So in 2015, I went back to the same university, so the University of Portsmouth, and then I did my PhD. But now my PhD was in applied maths, so that was applicable to
That's a big switch, yeah, from the theoretical stuff, sure.
Yeah, and that's when I realized how important maths is in a way, and how many problems you can solve with maths. In my PhD, we actually came up with a model. So we derived a model from scratch, and we were able to implement the model in Python and then get some data and then analyze the data. So we just became so real and so much interested. So yeah, I mean, that's when I fell in love with like data and even more maths.
Yeah, absolutely. And the really interesting thing that I hear from both of you is like, there was this one professor who made such an impression. And I would say the same reason I went and spent a lot of time studying what I did was I think it was like a Calc 3 class or something like that. And it was just such a great person I connected with and encouraged me to go down that path. And, you know, I see in my daughters who are in their second year, going to be in their second year of college, same thing. There was one teacher in high school that was just made such an impression. They're both doing their thing. And it's amazing how these small interactions can have such huge effects.
Yeah, definitely.
Yeah, Jennifer, how about you?
The question is how did you
get into like working with data and like sort of computational programming side of things?
Just the nature of the PhD I did, actually. So undergrad, it never crossed my mind to do anything particularly complicated, just regular biology type statistics, like t-tests.
Yeah, very yeah, exactly. Very few. Yeah, just enough to like do the lab work, right?
Yeah.
Very few people, I think, go into biology thinking I'm going to be a biology programmer type person, right?
No way.
But it seems to like draw you in, right?
Like totally accidental.
Slowly,
yeah. Went from t-tests and ANOVAs on a couple of subjects to doing so my PhD was looking at appetite systems, and it was a PhD that was it was in Manchester. It was the first time they'd had two different departments collaborate on a PhD. So it was between a traditional biology wet lab, which I was comfortable in, and the neuroimaging lab. So we were doing MRI studies to look at appetite systems. And of course, MRI, you've got 3-dimensional data sets. And if you take a brain image every 3 seconds, then you've got 4-dimensional data. And that requires a very different analytic approach.
Yeah, that's very different than taking measurements in a lab or growing something in a petri dish or something. Yeah.
Very, very different. You go in, then you're in the world of signal processing, which wasn't what I was expecting. So now you've got to deal with drift of the signal over time. And then there's so many different ways to pre-process signal data or time course data that not everyone agrees on how it should be analyzed. So that's fun as well. So yeah, at the time, there's several university-developed software that's specifically designed for MRI. And so that makes it open source because it's created with public money. There's 3 main software tools available. And then usually like user interface, you sort of click and build up your process that way. But they're also developed in the way that you can code it. Instead, you can write a bash script that will then link all the different steps together. And then you can do batch style analysis. So I guess that was my first entry into that kind of analysis using bash scripts, which was terrifying at the time.
Yeah, you're probably thinking, how did I get here? Like, this is not what I signed up for. I didn't. What happened, huh?
Yeah, but it drew me in, like you say, sort of got into it.
Yeah, I think, that's my theory about a lot of these things is people don't go into the data science side of this and that, all the data science Python tools necessarily because they start out with the plan to be a data science programmer type. They just they're doing work just like you described. And they're like, well, I've got to figure a little bit of this out because otherwise it's untenable or it'll be, 10 times more effective or whatever. And then a little bit more and a little bit more, then you look back and you're like, wait a minute, I've been programming all week and that's all I've done. Like, how did this happen? How did I get here, right?
Yeah, it's brilliant.
This portion of Talk Pythonomy is brought to you by Datadog. Let me ask you a question. Do you have an app in production that's slower than you'd like? Is its performance all over the place, sometimes fast, sometimes slow? Now here's the important question. Do you know why? With Datadog, you will. You can troubleshoot your app's performance with Datadog's end-to-end tracing. Use the detailed flame graphs to identify bottlenecks and latency in that finicky app of yours. Be the hero that got that app back on track at your company. Get started today with a free trial at talkpython.fm/Datadog.
I think it's going to be interesting though in like the next generation of data scientists, because I think we've all come from a background where data science wasn't a thing a few years ago. Like I only ever heard of data science when I was like finishing off like my PhD, probably in the last like year or two, where I was then looking for a career and starting to see like my peers a couple of years above me starting to apply for data science roles. Whereas now there's more data science courses. And I think, I say, you're going to then get a different breed of data scientists who have gone into it wanting to be a data scientist, not necessarily come into it from a different background thinking, oh wait, I've been doing MRIs and data processing, signal processing, and now I'm a data scientist.
Yeah. I think that's so interesting. Yeah, go ahead.
Yeah, I totally agree. I mean, a few years ago, when I was doing my degree, I didn't know nothing about data science. I think it's quite new, and it is sort of improving. There are new tools constantly being built. So it's very, I think it's an interesting area. So I think for anyone joining into the data world, they're realizing that there's so much to learn and to do. And it's just like finding out what you can do with the data. It's enjoyable.
Yeah. It's really interesting. I don't think that for very long there's been, I don't know how many data science programs there are where they say, here's a data science university program. I don't even know if they've been around long enough for people to graduate from them yet. You know?
I think there are some master's programs at the moment. So one year master's programs. Yeah.
So if they're 1 year, people there's probably some graduates, but certainly 10 years ago, I don't think it was that way. So it's a really good point, Kaylea, that when you kind of look out and you say, well, what can I do? You look at the degrees that you can go get and then what those kind of lead on to. And you're right that now I definitely think there's people that are like, oh, this AI stuff is really interesting. Machine learning is interesting. The visualization is great. And when I was studying math, the choices for what you could officially do with your math degree were extremely limited. It was, let's see, you could be, what's the analysis for life insurance?
But
actuary. Or you could go into like Wall Street, or you could be a professor or a teacher. And like, that was it, right? And I think that probably is happening across all these different areas. It's probably happening in biology and it's happening in economics and so on. And I feel like it probably, this side of the world has opened up new paths for all those different focuses as well. What do you all think?
Yeah, definitely. I think as well, it's good though, because it means that like we get quite a mix of backgrounds. So you do get the people that are now data science coming from a physics degree, biology degree. So I work at a company called Peak, where we've got a team of about 25 data scientists, and everyone's come from all these different backgrounds. And it's really great to then get sort of like the different expertise. Some people have different ways of like visualizing things. Some people have come from more computer science type degrees. But I think back to my point I made a bit earlier, it's like, if you're then going to just get students that are going to go straight into data science, you sort of lose some of that background and the expertise of different areas coming together.
Yeah. It sounds like everyone agrees on that. You all are shaking your heads, which no one can see on the audio, but yeah.
Yeah, for sure.
Absolutely.
And I think by working with people from different backgrounds, you get an opportunity to learn from them. And so I think it's great.
Yeah, for sure. You touched on what you're doing now at Peak with 25 different data scientists. Let's dig into that for all of you. So maybe you could expand on that just a little bit. Like, what kind of projects are you solving? What general area are you working in and so on?
Yeah, so actually I'm a bit of a weird one at the moment. So I'm in my last 2 weeks of Peak because I'm moving companies in a couple of weeks' time. So.
Okay. Yeah, maybe tell us what you have been doing and where you're going, or what your future holds.
So at Peak, we've got 25 data scientists. We're a company in Manchester, a startup-based company, who we sort of sell AI to businesses that don't have the capabilities in-house to do data science and machine learning. We've got a wide spectrum of customers, ranging from like household retail brands to like manufacturing. So within the data science team with 25 of us. We've got two teams. We've got one team that focuses more on like customer AI. So customer AI is things like recommendation systems, churn analysis, lifetime value. And then the team that I sit in is in the demand AI side. So we do things like demand forecasting, inventory optimization, warehouse optimization. So a lot of projects I've been working on are things like forecasting. So my background in time series analysis. So I did a PhD in change point detection, which I think is quite relevant at this moment that we're now in a big change in life, and like being able to detect change points and being able to work with them. Just a plug there for change point detection, I guess. So yeah, so that's how I've sort of come into this team. A recent project I've been working on has been more in like warehouse optimization. So we've got a retailer that are trying to optimize how they pick their clothing orders around the warehouse, trying to like come up with like the most efficient ways to walk around the warehouse to pick things up as quick as possible. So that's what I've been working on at Peak. I'm moving to a company called Residently in a couple of weeks' time, who are another Manchester-based startup, but they're more in, they do like sort of property technologies, like prop tech. So they've got like rentals. So a bit like, I guess, Airbnb, but more sort of long-term rental space.
Sure. Okay. Yeah, that sounds like a bunch of fun projects. Jennifer, how about you?
I'm now working at Lad Bible Group. So they were born on the Facebook platform. Now it's a website and on Facebook and all the other social media you can imagine.
Sure.
So I'm the lead engineer, data engineer on that team, on the data team. There's only 3 of us, so we're tiny. And currently...
some of those small groups, though, are so cool because you don't get pigeonholed into a little tiny thing. You get to actually see and work in the whole system, all the software, and it's hugely valuable. It's a little stressful because like all of a sudden...
everyone wants something, which is great. It's a great problem to have. And I wanted to work in a small company so that I can be involved in all the things because I want to do all the things. Everything interests me. I always want to learn new stuff, and this afforded me the opportunity to do that. So there's just 3 of us. We're currently working on a new data warehouse using Google Cloud Platform. So we've currently got a data warehouse, but we want to have a GCP. It can be more scalable and more robust. It's got great monitoring, and the dev team uses GCP as well. So it's good to be all on the same stack.
Yeah, nice.
Yeah. Also, you can use Python with it, so that's good. Yeah. So we've got big plans for that. Currently building out the data warehouse so that we can then carry out our big plans later.
Yeah, cool. The Lad Bible. This is like, it looks like sort of a new take on news in the social media landscape, something like that. Is that roughly right?
Yeah. Yeah, it's more lighthearted news, I suppose.
Yeah. Spreading
positive attitudes, which is really great. Like, I really like working for them. The teams are amazing. So great to work with. Yeah.
Yeah, it sounds really fun. And definitely something that we could use. Eslene, how about you?
So I also work for a startup company in Manchester. It's called Agent Software Limited. We aim to revolutionize the way estate agents across the UK market their services using targeted prospecting material. We've seen that agents have sort of seen sensational results with a fraction of marketing outlay. I work in the data team, so I work as a data scientist. I joined as a junior data engineer. I'm still learning about engineering, and I have a great manager. A great boss. He hates when I call him boss, but
I can confirm he's brilliant. He used to be my boss.
Yeah.
Nice.
Yeah. So we work on some great projects. So for example, the project we worked on about 2 weeks ago, we estimated the value of a property. So any properties in the UK. So we sort of started a model to get the estimated value of any property in the UK, which I think is great. And the one we're working at the moment is the propensity to sell. So that's the project we're working on at the moment. I think at the moment, I've got some features that we both agree to use. So it is great. I'm enjoying working as a data scientist, especially within the company, because, there are some amazing people and I get along with them. So it just makes life easier.
That's really great. It's interesting. I hear you all talking about all these people that you're working with, how great it is. And people who are coming in maybe maybe they're in academics or something, but they're not in the programming side. Maybe they think of the programming world as, you sit in a dark room by yourself and write code. And it doesn't sound like that's your experience.
No, that would be great. I wouldn't be against. I wouldn't be against that. There's a lot of people management, and not like managing a team, but talking to stakeholders, managing expectations.
Yeah, a lot of times you're the person between the people who want the software and maybe the customers or who's using it, and you've kind of got to juggle all that. Like that project management sort of side, right? Like, what are we going to focus on? What are we going to build for them, and so on?
Yeah, well, I mean, in our team anyway, we've got a project manager, and he's brilliant at helping to protect us from that and making sure our priorities are aligned with that of the business. I sort of code maybe half the time, and the rest of that's sort of planning and coordinating and meeting and discussions with people, trying to figure out what they need and what we can do to make things better, and all that kind of thing. It's good.
Yeah, that's cool. How about you others? Same time balance about, or how is it?
I think at the moment I do more coding. So I was team lead until last summer. So I had like a lot of time just spent like managing a team and setting them tasks, making sure everyone like was okay with the customer work, and sort of was that sort of in between sort of firefighting type role. But then I took a decision that I actually wanted to spend more time learning and developing. That's where sort of my Python development came up, because I was like, I just want to take a bit of time away from the team lead role and actually spend time coding. I think from doing that, I've actually managed to carve quite a lot of my time just to focus on the coding side of things and actually developing the models and doing analytics. And then we have a customer success team that are sort of the link between our customers and the data scientists. So they can do a lot more of the like customer engagement and making sure that the customers are happy and sort of communicating what we're doing for them. And we get a bit more time to actually focus on doing data science, which is really cool.
Yeah, that's great. Eslene?
I think at the moment I'm doing more research just for because we want to build a model for the propensity to sell. I'm doing more research, but at the same time, by doing research gives me sort of an opportunity to learn new techniques and new tools. So yeah, I'm not coding at the moment, but I am missing it.
Yeah. Well, one thing I think is worth talking about maybe is all of your backgrounds were not officially in computer science from the beginning, freshman year in university, and neither was mine. And that means when you get into the industry, it's a lot of like what you described. It's a lot of research, a lot of figuring out like, oh, I know this, but now they're asking me to do this other thing. I have no experience. Like I have no idea how to talk to a database, but apparently this is what I'm figuring out soon, right? Like that kind of path. Do you think that your academic backgrounds and just the whole sort of advanced study side of things just kept going when you got into the tech industry? And was it helpful? Yeah, Jennifer?
Yeah, absolutely. I think, I don't know what people imagine on the whole when they think about what's different between academia and industry, but there's a lot of transferable skills between PhD and industry. So planning experiments or planning projects, that's the same. Research. So like when you go onto a new project, you've got to do the research to figure out like what's been done before, what hasn't been done yet. So how could you go about testing something or learning something? That's the same, which Eslene just described. And yeah, you come up with, you're given new tasks. And you're like, well, I've not actually done that before. Like I've not done recommendation systems before. I've got to figure that out. You're still mentoring. So the higher up you go in academia, you start mentoring students. You do the same in industry.
Right, like maybe you're a TA teaching a class while you're doing your research or something like
that.
Yeah,
exactly. Sure. Yeah. And you're mentoring junior or foundation level data scientists or whoever when you get into industry. You're always learning, using your reasoning skills really to get through any of the work that you do. Is the same in academia as it is in industry. There's a lot of overlap between the two.
I think definitely my sort of academic background has taught me to be sort of curious and to keep asking questions when I'm doing tech. Especially it's quite easy as data scientists, I think, to sort of get your data, run it through some sort of like scikit-learn type model, get the results.
Here's the answer.
And then just go with it. And I think what a PhD has sort of developed is that sort of deeper thinking of, but why is that the answer? Can I explain that? What happens if I change something? And I think I've like interviewed quite a lot of data scientists over the past couple of years, and you notice more sort of the ones that have come more from a junior level that have maybe just come out of a master's haven't quite developed that sort of questioning, because it's sort of what comes from doing a PhD and diving into much more deeper analysis on things, that they're sort of just, they get the results, but then when you sort of dig into like the question and say, why is that the answer? How did the model perform? how does it work? They're sort of as unsure about that. And I think that's something that I've sort of been trained to sort of keep questioning during my PhD, which I sort of then brought to tech.
Oh yeah, super. Eslene?
Yeah, I think it's the same for me. I think my PhD has really helped me to think things through and to question myself and to double check and check again and to test my work really, whether I implement it in Python or even doing some analysis. I think it's really helped me in that way. Because I think when I did my PhD, one thing I learned was just because you've done some mathematical analysis doesn't mean it's totally right. It's good to prove it by doing some programming as well. It's much more, it just makes it a lot more fun. And also you're able to show what you've proved mathematically. You're able to show it as a graph, for example. So people can actually visualize the maths behind it, even if they don't quite understand the maths. As soon as they see graphs, they get a bit happy because, yeah, that's something I'm really grateful to have learned whilst doing a PhD.
Yeah, absolutely. It does really make it much more concrete because maths can be so abstract and out there. And once you either make a program that can, say, do a recomendation or it can generate a picture, all of a sudden it's like, oh, look, it's kind of real. It sort of exists, at least visually.
Yeah, totally.
Yeah. So, all right. So here's like one of the big questions, I think, of this conversation. You all talked about your background in academics and studying and so on. And you're all working in the tech industry, not doing biology or statistics or complex analysis or whatever, it is in the math world that you thought you might have been doing. So what was the thinking there? I could tell you when I sort of dropped out of my PhD program, which I did halfway through, it was a big decision and it like kind of weighed on me for a while. It doesn't anymore. I'm all great with it, but best decision ever. But what was your thinking? Whoever wants to jump in first, go for it.
I think I always sort of knew that I would probably end up in industry, particularly like sort of halfway through my PhD. So because the way our doctorate training centre was sort of set up, it was set up to work with industrial partners. So we had a lot of our PhD projects were with industrial funding. Mm-hmm. So I did mine with a company, DSTL, which is Defence Science and Technology Laboratory. And like within my PhD cohort, there was 10 people in my year, and everyone sort of had a different industrial partner. And within that, the industrial partners would come and present to us. We would have like regular problem solving days where they would come in the morning. It sort of be like a mini hackathon where we'd get to work on practical problems.
That sounds so cool and like really useful, right? Not just like you're going to study the theory and then you're on your own. That's great.
Yeah, so it was like a really applied PhD. So even though we were spending time researching and doing our own work, the Doctorate Training Centre also put on all these other events and sort of things like conferences where there'd be half academic speakers and half industrial speakers. And I think I was always more interested to go to the like industrial talks, so that people like using tech in industry because they're more applied. I could see the reason behind doing them. I think academia, you spend a long time sort of trying to develop novel areas and trying to prove them like asymptotically or whatever. Whereas I think I was much more of I know the tool set, or I'd like to go and research what tool set to use and then apply it. So I think it was always sort of more in the applied sort of side.
Yeah, that's a big difference, right? You don't get credit for just necessarily finding interesting uses of existing technology in academics. It's always about what new problem new question are you answering, right? And so it's a big difference.
Yeah, and I feel it's always very small incremental changes that you might be making. Someone's done it, that like there's like years and years of research and you might be changing a parameter or doing something quite small. I also think that academia is a bit sort of outdated in a sense, so it's a bit slow. So like the time you publish papers, and then it goes through like all your reviewers, and then you do all your edits, and then you eventually get your publication like submitted and published. That could have taken like 2 years. Whereas in the industry, you could have your project in sort of a developed, like productionized thing ready in a few months, and then start to see the value generated from it.
Yeah, it's a huge difference. Yeah, for sure. Eslene?
Well, when I finished my PhD, I didn't. Well, just before I finished, I didn't know what to do because I enjoyed working in academia. I was working, whilst doing my PhD, I was also helping undergrad students with their maths problems. So I enjoyed talking to people, explaining, and just interacting with students. I really enjoyed it. So when I finished my PhD, I applied in academia, and I also applied in the tech industry. So I just said to myself, the first job that comes along is the one that I'll go for. So I first worked as a Python developer. I think that was really good. I worked for a year, and that was a great opportunity for me to really improve my Python skills, because I was using Python on a daily basis. But I was missing my maths because it was mainly
sure.
So I really missed it. So that's why I started applying for data scientist roles, and I did get one. But I think for me, I am in the tech industry, and I really enjoy what I'm doing. I feel like I'm doing everything I've always wanted to know, I always wanted to do, because I do enjoy programming and I also enjoy maths. So having both just makes me happy. At the same time, in terms of interaction, I do interact with my peers, so I'm not really missing out. But yeah, before I finished my PhD, I didn't know what I wanted to do, mainly because I was wondering whether the level of interaction in an industry will be different to actually lecturing, but now that I do know, it's not really different. So
yeah, one of the things I thought I would miss the most, that I thought I was giving up, was that teaching side of things, because I was teaching when I was in grad school. I was teaching all the levels of calculus and linear algebra and those types of things, and I really enjoyed that, probably more than actually studying math directly. And I thought, okay, well, if I'm going to programming, I'm definitely giving that up. And that seemed like a huge thing. And then it turned out that I ended up doing like professional development training stuff later on, and I kind of got it back anyway. Yeah, it's not as big of a trade-off, I guess. This portion of Talk Python to Me is brought to you by Linode. Whether you're working on a personal project or managing your enterprise's infrastructure, Linode has the pricing, support, and scale that you need to take your project to the next level. With 11 data centers worldwide, including their newest data center in Sydney, Australia, enterprise-grade hardware, S3-compatible storage, and the next-generation network, Linode delivers the performance that you expect at a price that you don't. Get started on Linode today with a $20 credit, and you get access to native SSD storage, a 40-gigabit network, industry-leading processors, their revamped cloud manager at cloud.linode.com, root access to your server, along with their newest API and a Python CLI. Just visit talkpython.fm/Linode when creating a new Linode account, and you'll automatically get $20 credit for your next project. Oh, and one last thing, they're hiring. Go to linode.com/careers to find out more. Let them know that we sent you. Jennifer, how did you? It sounded like you were working a little more close to where your degree was. You know, when you said working in Baltimore and so on, before you moved over to what you're doing now.
Yeah, so I did 6 years postdoc after my PhD, and that was just more MRI. It was brilliant. That's how I got into coding, and I really liked. So yeah, it's still academia, but in I guess the government research space.
Yeah.
So still not industry. But yeah, the analysis was great. Experiments, brilliant. Like loved all that stuff. But I'd always be attracted to the sparkly new technology. Like there's this new technique, and I'd think, oh, I want to do that. But it's like, no, that doesn't answer this. It's the question first, and then you pick the right approach. And that's still true even in data science and industry, but it's a little bit easier to handle now. Also, I'm aware of it now, so I know when to stop myself. But yeah, projects were really long. So one experiment from beginning to end of potentially having finished the paper would be like 18 months, really long experiments. So that I don't have a very long attention span, so that's not great for me. Also, once I've done the experiment, I've got the answer that I was looking for, but then you've got to write up the paper. But I'm interested in something else now.
Right, you're kind of done with it, but there's all this work you got to go through and peer review and revise and resubmit, all that. Yeah,
and you've got to write introductions and stuff and justify what I did, and it's a really long process. And I want to do the next thing by then. Also, there's not really much feedback. You know, you submit the paper and it's so niche, and then you get nothing back. Like, what I do change anything? Did it progress anything? You might get some references or citations later, but it would be, a year or two, you might get 5 citations, and like, did that mean anything? And those citations might not even be positive about your paper. They might be saying this experiment was bad, and we're going to do it differently. Yeah, exactly. So
exactly,
it's very unhappy all around. So I didn't know going into industry would solve these problems at the time, but I feel like, at least in the companies that I've worked for so far, they've both been very small companies. The projects are much more shorter. They're more defined. They're worked in smaller increments. You get feedback quicker and directly with the people that you're doing it for. So that's really cool. And there's no papers to write.
Yeah.
Yeah.
I do think there's the opportunity to iterate. Y'all have touched on this, that you iterate on something, you can go from idea to making a difference or making an impact in a month or two instead of, did you even make a difference?
Yeah.
The thing that really drove me crazy about the academic side was once you really get to the point where you're doing official academic stuff, so often it's extremely limited. You know, there's 20 people in the world who potentially could care and half of them don't. You know, it depends on the area, but it can be very, very small. I remember, and you can write software that is used by millions of people or makes huge differences. And it's a big contrast.
Yeah.
I agree. And also like in industry or like in programming, there's a lot more like open source. So you can get your function out there and people can use your function, whereas it can be quite difficult to actually access papers. So even if you then publish a paper in a journal, unless you also work in academia, you can't really access papers unless you pay lots of money or find someone that can access it for you.
Does that seem crazy to you that so much of this research is government funded, publicly funded, but is locked up behind these extremely expensive journals?
Yes. Drives me nuts. They get paid twice because you've got to pay to submit your paper and then you've got to pay to read it. Yeah. And it's peer reviewed by academics who are doing it for free.
Yes, exactly. Like
it's ridiculous.
People who work on it. I know some people at the journal get paid and do work, but the reviewers, it's like part of their commitment to being an academic. Yeah.
Yeah. I have feelings about that.
Yeah. Yes, so do I.
The whole long
yeah, that's another episode perhaps. Interesting. So that's really interesting. You know, when I made the switch, it just seemed like a lot of what you were all saying really was part of it. I felt like I wasn't going to make that big of an impact. I felt like what I was doing was actually much more interesting. I also thought the employment story was really challenging in the academic space for me. You know, just talking to the people who were graduating a year or two ahead of me, how many applications they had. Like I applied for 105 positions. I got 5 responses, 2 interviews, and 1 postdoc offer for 1 year that I can reapply for. Like, whoa. This is like a good university. You got your PhD. There should be more than 1 offer in the entire realm of what you can apply for. So I'm just like, wait a minute. This is a little bit crazy. So yeah, there's definitely a lot of benefits. One thing I did want to ask you all is, what advice would you give back to people who are, say, in academics now, not necessarily like, oh, you should move on because whatever, because there's a lot of good stuff happening in academics as well. But you know, what are some of like the data science techniques or programming tips or career advice would you give to people who are maybe working in, getting their PhD or master's degree or something like that?
I think I'd say to try, if possible, to get a little bit of experience in working in industry. So whether that's trying to find like an internship or fellowship, I know some sort of PhD courses or master's courses actually offer that, where you could take like 3 months, maybe sabbatical from your PhD and go try doing something in industry. Or there's, I think in the UK, there's like KTPs, which are knowledge transfer partnerships. I guess there might be similar things over in the States, just to get that sort of experience of trying both academia and research and industry, but also to speak to people in industry. Because I think there's like, data science is such a wide spectrum of a career that there's different parts to data science that might interest different people. And someone that's sort of spent a long time in academia and is possibly going through and done that a few postdocs might find themselves wanting to go into more of a research post in industry, where they could get sort of that hybrid of still doing research for a bit but doing it in industry, which would then give them sort of like a foot in the door. And then they might realise then that either they want to stay sort of more research, or they might think actually the applied side is quite fun.
Yeah, that's a good point. There's a lot of companies that have little research projects going on inside them, and you could definitely find yourself there. Eslene?
Yeah, I mean, I would say just be open to new opportunities. So like, for example, if you're doing your PhD at the time, just make sure you take part into teaching, for example, just to see whether you'd be comfortable doing it as a long-term career. And also, again, like Kaylea said, just go for at least just work in an industry maybe for 1 month or 2 months just to see if you're comfortable. And yeah, and also just don't worry too much, I would say, about the money when you finish your PhD. Just make sure you get the right experience, and just make sure you also learn new techniques, new tools, because yeah, I'm sure you get plenty of money later. Oh yeah.
Yeah,
to begin with.
That's a great point, because I think the hardest part about getting a job in industry and data science programming side of things, the hardest part is the first job. Go from 0 to 1. And once you've had that first job for a year or two, all of a sudden many opportunities open up to reposition yourself or to get a big raise or move up or whatever. But getting that right experience is important. I agree.
Yeah.
Jennifer?
Yeah, I think most don't have much to add to that. Is really good advice. But sometimes it can be hard to find people in industry to even talk to. So I definitely recommend going to meetups. You can meet all kinds of people who work for all different kinds of companies. I think a lot of my concerns about working in industry are ones that would be true in big companies, like really, really big companies that are not that don't exist or aren't so apparent in smaller ones. For example, being siloed into small, very specific kinds of work that might happen in a much bigger company, or stringency to software engineering processes. Or even just knowing that like some data scientist jobs are more R&D, which might be more similar to your academic style of working, and others might be more about like data engineering or productionizing data science analysis models, machine learning models. And so that's very different kinds of working that one of them might suit you better than the other. So just knowing that those are out there and what benefits different kinds of work environments might have would be good to know.
Yeah, there's a really big difference between taking a ML model and then writing an API to make it go versus researching what parameters you use to predict the likelihood of selling a home.
I mean, working on toy data to get like the most accurate model is one thing, but then optimizing it to work for masses of streaming data is on some kind of cloud platform is a completely different problem. Yeah. And you might have to make sacrifices of accuracy for speed, or any kinds of those, and they're all different kinds of problems. So yeah, you can meet, or even you might not even want to go to industry. You might want to work for public service or government.
Right.
That's not necessarily industry per se, but also not academia. There's a lot out there, and you can meet all these people at meetups. I recommend.
I think to add on to that is like meeting people at meetups and trying to get an understanding of like what the data teams are like within companies. Especially if this is going to be your first job out of academia, it's probably best that you find a company that already have a data science team of sorts in the company. You don't really want to be the first data scientist, because then you're not going to learn from anyone. And I think as well, like if you've been in academia for years and years, and if you've gone like postdoc, maybe some fellowships, and then you decide you want to make that change, you sort of have to understand that you're no longer the expert. I think you build up quite a deep expertise in academia that you could all of a sudden become the expert in this sort of really, really niche field that only other like 20 other people are part of. But as soon as you go into industry, you realise that actually there's now a broad spectrum of data science skills, and you're no longer the expert, even if you've got 20 years in academia. So you sort of have to take that step back and say, right, I now need to learn this whole range of other skills.
Yeah, it lets you identify where you really are interested in, right?
Yeah, definitely.
Yeah. Well, that's all really good advice. And I want to second the idea of going to meetups and those kinds of events, because the earlier you are in that transition, the harder and the more alone it feels, and like the less guidance I think you feel like you have. And you can go meet other people who are in the same situation, or more importantly, maybe they're 1 year farther down the path, right? They've made that step and like, this is what worked for me. I also want to encourage people to offer to speak at these meetups, because I think that makes a huge, huge difference. I know when I started speaking at things like code camps and meetups and whatnot, it gave me a much greater interaction with the community. I started getting job offers that I didn't know that I wanted, but I'm wait a minute, really? I could go do this? It's not nearly as intimidating as it sounds. And coming from academics, you're used to giving presentations anyway, right? So if you can find something focused enough, meetups would love to have a 30-minute talk on something that you've been studying, and then now you're doing computationally, right?
Yeah, I'm sure Kaylee can agree that it's always Kaylee used to organize Our Ladies, right?
Our Ladies.
Yeah.
Yep.
And
Our
then,
Ladies Manchester.
Yeah.
Nice.
And I currently organise Pi Day in Manchester. And yeah, looking for speakers. We would love for people to just offer us to talk on any of our meetups. To be, always open.
Yeah. And I don't want to speak for you two, but in general, I think if you were to say, go to an organizer and say, I would love to talk about this, but could you give me just a little bit of advice and guidance and feedback just to kind of mentor me of like, what is expected? Would this resonate? Just a little bit of help for your first presentation. I'm sure you could get that help, right?
Oh yeah, definitely. Yeah. Actually, we were thinking about having a meetup event. I don't think we've nailed down the details yet, but we were thinking of having a session just like that to try and encourage people to talk. Because especially depending on especially depending on where they are in academia and what they're studying, they might not have as many opportunities to give presentations. So they might not be as experienced.
Sure.
Yeah.
Yeah. No, I think that's great.
I think in data science, it can be very hard, very easy to feel a bit like an imposter because there's so much going on that you think, I don't know enough to speak at these events. And what I found recently is actually finding what I did during my PhD, and I did change point section. I've now done quite a lot of talks on that because I found that when I do talks, it's something that I know about, but it's also something that other people don't know about. So then they like to come and ask questions. So I think even though you might think your topic is only small or isn't as broad as some of the other data science topics, once you start to present it and get more comfortable presenting something it then makes it easier to present on something you don't know as much about, but you're sort of trying to learn about.
And it's easy to think everyone knows more than me. When I go on the internet, everyone seems so smart. I have no idea. But then in practice, you go and you give one of these presentations and you might ask all right, who has a lot of experience doing this thing I'm about to talk about? And you're thinking everyone's going to put their hand up and 2 hands out of 20 go up. You're like, oh, wait, these people don't have a lot of experience. I'm going to be able to teach them something. And I think that's actually really surprising and great.
Yeah.
I also actually think it works the other way because even if you presented something that there was an expert in the room, that's probably a good thing as well because they can then give you the feedback that you might not have got from anyone else. And who can then actually mentor you or train you or welcome you into their team and say, we're actually doing something like this, come and join us.
Yeah. But anyone else, but I find giving a presentation helps me learn more about what I'm talking about as well. I might think I understand, but it's not until you try to explain it that you realize there's holes in your understanding, and then you have to go and sort of fill in those holes.
Oh, absolutely. I think that getting some concept put together so you can present it clearly, you've got to figure out what is the essence of this thing. You've got to distill it down. And also you have to just have a different way of thinking about it. And I think the PhD research side of the world works really well here because if you're going to use some technology in a program, you just have to get some way to work. There might be 3 ways you could solve this problem. But if one of them works, you're done, right? The problem's solved. But if you're going to talk about it, you have to say, well, there's these 3 ways. And in this situation, you use this one, but that situation, use that one. And here's the trade-offs. And that kind of deeper level research, I think it really matches well with those kinds of presentations.
I think one of my goals this year was to actually do a talk, but obviously coronavirus happened.
Yeah, so that is so unfortunate. But yeah, so what were you going to talk on? What were you thinking?
Well, actually, I hadn't decided, but I just wanted to pick anything, even if I wasn't good at it, just to pick one topic and just do some research, learn about it, and then do a presentation, and then talk to, for example, Jennifer, because she has more experience. She's done so many talks at those meetups, and talk to someone who's more experienced and show her, for example, my presentation, and just to get some feedback. I love feedback. And then to go out there and give a talk. So that was one of my goals. I don't know if it's going to happen, but fingers crossed. Let's hope all this just there
are
I hope
some
so.
virtual meetups happening. So I'm talking at a virtual meetup on Thursday. So Her Plus Data, which was the event that inspired this podcast. It actually got cancelled a few weeks ago because of coronavirus, but they've moved it to a virtual meeting on Thursday. I don't know if that makes it better or worse, speaking to a screen where you can't get feedback from anyone. But if they're going to do another virtual one, you could if that interested you, you could try and get on the speaker lineup for the one after.
Thank you. Yeah, cheers.
Yeah, absolutely. And I don't know if it makes it easier or better. I've done a lot of in-person presentations, but also virtual ones. And they both have their own challenges, right? If you stand in front of a crowd of 500 people, that's intimidating. But also if you just stare at your screen and you have no feedback and you don't even know for sure if your audio and video is cutting out and they're even hearing you, like that's also really, it could be distracting and hard. So yeah, it's different challenges, but I'm glad you're still getting to speak. That's great.
Yeah, I mean, Pi Data Manchester we had our first live streamed panel event a couple of weeks ago. I think we had everyone on a hangout. The 3 panelists and the person asking them the questions on a hangout, and then that was streamed to YouTube live. And I think that might have been odd for the panelists as well, because they didn't have, as you said, they didn't have any feedback. They could only see the other panelists. Right. They could only see who they're directly talking to. They didn't have YouTube open and have access to like how many viewers it currently had or what comments were going down the side or whatnot. So yeah, it must be quite odd.
Yeah, it's a challenge. You want to give a quick shout out to Pi Data Manchester? You all seem like you're involved in that, and it's if you're doing virtual stuff, people could attend from all over even.
Yes, let us know. Eslene as well, of course. Maybe you'll get 2 or more speaking opportunities this year, which would be fabulous. Yeah. We do. Great. Yeah. We got monthly meetups and a monthly code night where you can bring a project and get help and give help. And we also do monthly podcasts.
Super.
Yeah. Yeah. You'll have to give me the links to put in the show notes so people can check it out.
Cool.
All right. Well, ladies, we're getting close on time, so I think we'll have to leave it there. But it's really interesting to get a look at how you went through your academic side of things and then moved over and what you're doing now and that perspective. It's been really, really good. But before you get out of here, you got to answer the 2 quick questions at the end, which are, if you're going to do some data science, write some Python code, what editor do you use? Jennifer, go first.
I jump around between 3, depending on what I'm working on or how I'm working. Atom, Spider, and Jupyter notebooks. Okay. Or Jupyter Lab, I suppose.
Right on. Yeah, sure. That's the next one, right? Latest. Eslene?
Yeah, I use Atom, Spider, and Jupyter as well.
Yeah, those are great. Kaylea?
So I mostly use R, so I'm an R Studio person because I think that's the editor for R. But when I'm trying to do Python, I'm using VS Code at the moment.
Cool, yeah, they're doing neat stuff there, yeah.
I've heard good things about VS Code, though.
Yeah, I really like it. I tried using Jupyter Notebook, but I'm not a huge fan of notebooks, so VS Code seems to work well.
Yeah, they've got some really good plugins.
Oh, yeah. I don't think I've fully experienced everything it can do, but I think I've probably set it up to run too much like RStudio, so I'm probably not doing things in Python anyway.
There's so many options in that, all those extensions there. Yeah, you can go. Everyone can have a different experience with the same thing, pretty much. Yeah, for sure. All right, and then maybe one of you could throw out a notable Python package that, or a couple of you, whoever wants to, notable PyPI package that you recently used that was awesome or worth telling people about.
I'd say
Sublime is good.
I'd say
no, you can go.
I'd say Vader Sentiment, which is an analysis tool specifically for Twitter text tweets. So it's NLP, but takes into account how people tweet, which is not like how people officially write.
Right, because you couldn't feed it like an article, train an article, and then feed it a tweet. It was like, well, this person's really frustrated because they are really terse. No, that's the limit.
If it's a word written in all caps, it takes that into account to weight the score, or how many exclamation points are used, or I think also emoticons or emojis. So it takes it sort of understands tweet speak, as it were.
It's data sentiment, huh?
Yeah, Vader, like Darth Vader, Vader Sentiment.
Vader.
Yeah. VADER Sentiment. It's a GitHub project. I'm not sure if it's PyPI.
Cool. Yeah, I see. It's on GitHub. I'll put it in the show notes. Very cool. Very cool.
Yeah, I was going to mention Sublime Text. So that's more like a sophisticated text editor for code, markup, and prose, and also Data Grip. So Data Grip is that provides context-sensitive code completion. So it's good for SQL queries and
Data Grip is super cool. It blows me away. Like you can do a query and it just understands all the different structures, and then it's also built into PyCharm. And in PyCharm, if you write a string in a Python program, it'll autocomplete inside the string the stuff out of the database, which is just like crazy. So anyway, it's a good time to be programming. The tools these days and the libraries are so awesome.
Yeah.
All right. Well, that's it for our show. Ladies, thank you for being here. It's really been fun to talk to you.
Thank you so much.
Yeah, thank you. It's been really great.
Yeah.
Yep. Cheers. Bye.
Bye.
Cheers.
This has been another episode of Talk Python to Me. Our guests on this episode were Jennifer Stark, Kaylea Haynes, and Eslene Bikoumou. It's been brought to you by Datadog and Linode. Datadog gives you visibility into the whole system running your code. Visit talkpython.fm/Datadog and see what you've been missing. They'll throw in a free t-shirt. Start your next Python project on Linode's state-of-the-art cloud service. Just visit talkpython.fm/Linode, Linode. You'll automatically get a $20 credit when you create a new account. Want to level up your Python? If you're just getting started, try my Python Jumpstart by Building 10 Apps course. Or if you're looking for something more advanced, check out our new async course that digs into all the different types of async programming you can do in Python. And of course, if you're interested in more than one of these, be sure to check out our Everything Bundle. It's like a subscription that never expires. Be sure to subscribe to the show. Open your favorite podcatcher and search for Python. We should be right at the top. You can also find the iTunes feed at /iTunes, the Google Play feed at /Play, and the direct RSS feed at /RSS on talkpython.fm. This is your host, Michael Kennedy. Thanks so much for listening. I really appreciate it. Now get out there and write some Python code.